All right, so we finished this one. Let's do another one. We're going to do the same problem, except this was 95% confidence, and I want us to do 90% confidence. Okay, so 125. Right, we're still using the same formula. Minus the alpha over 2 sigma square root n mu plus the alpha over 2 sigma square root n o. All right, and so we need the value of all these. X bar, the alpha over 2, sigma, and n. N was 40. Sigma we said was 53. We're at 90%, so it's going to be 1.65. X bar was that 125.3, right? 125. All right, and so I'm just going to fill in the blanks. 125.3 minus 125.3 minus 1.65 times sigma 53 over square root 40 mu 125.3 plus 1.65 50 square root 1. All right, and I always do margin of error part first, so I'm going to do 50, come calculator, 53 divided by 40 is 8.38 times 1.65, so 13.8. So it's 125.3, give or take 13.8. Okay, and then if I want to write it as an interval, I'm going to do 125.3 minus 13.8. I get 111.5. And 125.3 plus 13.8. I get 139.1. All right, so I'm 90% confident that the number of friends is 125.3, give or take 13.8, or I'm 90% confident that the number of friends is between 111.5 and 139.1. Notice, 90% confident, what changed was the margin of error, which is what we had calculated above in a different video. Okay, when we were 95% confident, whoa, Nelly, 95% confident, it was 16.4 was the margin of error. And so it was between 108 and 141. 108 to 141 for 95. And at 90%, it's tighter. It's 111 and 139 versus 108 and 109. So if we did 99%, it's going to be even bigger. Let's see. I think it's next. Yeah, 99. Same thing. X bar minus C alpha over 2 parentheses sigma square root n over mu 2 X bar plus C alpha over 2 sigma square root n. And we need all those numbers. X bar was the 125.3. C alpha over 2. 99% is 2.58. I don't know why I'm like having issues. 2.58. Sigma 53. N is 40. So I just plug it in, plug it in. I am so sorry. You don't have to believe me, but I just swallowed a fly. So that was super fun. What do I get for opening my big mouth? I guess. Oh gosh, y'all. I'm just okay. Let's do this. Oh my gosh. I don't even know if this ever happened before, but it was so fun. All right, X bar. 125.3 minus 2.58 parentheses. Sigma is 53. Third N is 40. And we're going to do the same thing. It's going to be 2.58, 53 for 40. All right. I'm going to do the margin of error first. Margin of error is right here. 2.58 2.58 times parentheses 53 divided by square root 40. All right, I get 21.6. 125.3, give or take 21.6. Right? And then I can do 25.3 minus 21.6, 25.3 plus 21.6. I get 103.7. I'm writing with my opposite hand, in case you're wondering what happened to the handwriting. It's even worse than it was before. 0.9. And so that's my margin of error. Oopsies. That's my margin of error. All right, and these are my two answers, depending on how I asked for it. All right, so let's compare these. So 99%, it's between 103 and 146. 95% is 108, 141. 90%, 111, and 139. So as your confidence level increases, so does the margin of error. Because the more confident you are, you need to leave a little more wiggle room. Is what I'm trying to show you here. All right, so we've done it by hand, and it's so super fun. But I want to show you by the calculator. So these are the steps. Sometimes, like this problem, we had data, and so we put it in list 1, and then we tell them the confidence interval. Sometimes it will just straight up tell us the information, and that's when we put it in stats. Regardless, what we do is we're going to push stat because we're in statistics. Then we're going to go to tests, and then we go to the z interval, and it will calculate the information for us. All right, let's do it. Y'all, I can't believe I just swallowed flat. Like, we need to find the statistics. Like, yeah, it's ridiculous. All right, so we know we use z, like this formula. That one, plus or minus, because it says population. The population standard deviation, right there. All right, and then the rest of it, like we're going to learn in the next section, not necessarily the next video, but the next section, that when we don't know the population standard deviation, we use a little different formula to make sure that things aren't skewed off. All right, so I'm just going to write down everything they give us. Large department store averages 362, standard deviation 29.6, confidence interval is 99. That means that z alpha over 2 is going to relate to 2.58. All right, and I'm just going to type that in my calculator. All right, so stat, test, there we go, stat, test, And I want Z interval because we're in interval or in confidence intervals. Later, in the next chapter, we're going to learn about that stuff above. All right, and so I have stuff in data. All right, and so, oh, no, I don't. This is totally different set of data. So I'm going to go to statistics. All right, I'm going to go, okay, standard deviation, 29.6, X bar 362, in, how many are there? What open? Oh, 40 hours, 40, and we want 0.99. All right, let me show you. Okay, so I just typed it all in there. Calculate. There we go. So I'm 99% sure that it's going to be between 349.94 and 374.06. All right, I'm going to write this down, and then I want to show you 3, 4, 4. Okay, it's a 4. All right, so if I wanted to write it that way, great. If I needed to write it with a plus or minus, 362, then what I need to do is to find that error, all I have to do is 362 minus 349.94 and see if that's the exact same as 374.06 minus 362. And it is 12.06. And so regardless of how I ask for it, you can still find it. And look, that took us 2 minutes, a minute, versus it was taking us like 5. Let's do another one. So this means I'm 99% confident that the number of customers per hour in a sample of 40 hours is going to be between 349.9 and 374. Or I could say I'm 99% confident that it's going to be 362, give or take 12.06. All right, let's do this one. I'm going to come back to that one that I missed. But I just went. All right, so the mean, so there's 20 kids. The mean is 22.9. Past studies, the population standard deviation is 1.5, and we want 95%. All right, that's test, Z interval, 1.5, X bar is 22.9, there are 20, and we want 0.95. Okay. That's what I get. Let me write it down. So it's going to be 22.243, 23.557, or I could say 22.9, give or take. And now remember to follow that, or to find it, I just have to do 22.9 minus 22.243, like minus each of the numbers. So 22.9 minus 23.557, and I still get 0.657, so that's the margin of error. So I'm 95% confident that the mean ages of the students enrolled is between 22.2 and 23.5, or I could say I'm 95% confident that the mean of the ages is 22.9, give or take 0.657 years. All right, the next video we'll do some more examples. This is a super important concept.